Thailand. So please come to Thailand again. So if you have some time. So that's a very beautiful place, and cherry blossom and tulips. And the mountainside is also a nice place, and so there the cable car. And winter time is also very beautiful. Wow. So and the Japanese food is also nice, and Thai food is also nice and my favorite. So let me introduce the newly constructed buildings only for realizing recycling technology of aluminum in Japan. This is only building and only facilities in Japan to promoting recycling process of aluminum alloys scraps in Japan. The 3 stories building is very small, but it's enough for us at the moment to open the door to how to realize the aluminum scraps to aluminum products by reducing the amount of impurities or additional elements that was in their originally in the aluminum scraps. For example, so if you have the aluminum can that contains some amount of manganese, but if you go to the window, so there's a window frame, sash, that contains magnesium and silicon and some other elements. When you go to your car, open up your car, so you see the engine. So that is aluminum silicon alloys containing much amount of silicon, about 10 weight percent or more. So if you go to the window frame or panel of the body car, so we have to reduce the number of silicon from 11% down to less than 1%. Maybe 5% is okay for the gigacasting, which is emerging in European car producing industries. So the point is silicon at this moment in Japan. So we are trying to reduce the silicon from aluminum scraps. This is a key issue of my talk today. Okay, you got me? Okay. Sorry, the next slide. And in Japan, I have talked to many companies saying that your products will not be bought in Europe in some days. They say, why, Toshio, why you say so that? So I said, in that country, in that area, there will be very strong regulations concerning treatment for recycled materials. When you go to the car companies, so they are trying to use recycled materials. For example, plastic material that we should be 25% of plastic material should be used for car producing. What about the aluminum alloys? It's about and let's see, 15% was its weight. Aluminum alloys are now used, but it's increasing its number. More than 40% of car body will be constructed using the aluminum alloys. How can we do this? So in Japan, we have only we only import aluminum ingots. We cannot smelting inside Japan. So that's why this is a serious problem in my country. And plus, the environmental conscious countries such as Italy and Germany and France, they will refuse our products because Japanese products contains so much amount of carbon dioxide during processing, during buying some raw materials from the other countries. For example, in case of aluminum, when you go from bauxite to produce, refine, the smelting aluminum ingots, how much amount of CO2, carbon dioxide, will be exhausted during that process? It may 10 times of its weight in my country, in my case. So if you use fresh, raw, beautiful aluminum ingots, it's not beautiful. It's also dirty aluminum because it has exhausted so much amount of carbon dioxide. If you use that raw material, dirty aluminum, raw material. What can you say that, hey, my product is very beautiful and we are environmental conscious, obsessed company. So it's not actually. So your company produces so much amount of carbon dioxide during the production process in your company. So we do not buy those things. So within 10 years, that situation will attack Japan. So I talked to many companies again and again. So now they are changing their mind gradually. So next slide, go to, this is important. The upper slides, please look at that. So Japan has we say cascade producing system coming up, all right, and mass production, mass consumption, and mass amount of waste. This one way. So from of course we do recycling those waste, but again and again we do the recycling. The impurities increases its amount. So first we do the aluminum rolled sheet or extruded bars. But second time or third time, we have to use those recycled materials for producing casting, only for casting. That is cascade. So our challenge is to upcycle recycling, so reducing the amount of impurities from the aluminum waste. So that is very important, but very difficult at this moment in Japan. So if you have some ideas to overcome this problem, you'll be a millionaire. I mean that. So the point is how to reduce the amount of impurities. Yeah, but if you go to the textbook of aluminum, you see that thermodynamically that is also almost impossible to remove impurities from aluminum alloys because of the thermodynamic reason. What we've been working for this program is that we are using solubility limits for each element in aluminum. But anyway, so we have constructed this scheme, this system to realize how to realize the impurity reduction aluminum products in one stop. We say one-stop problem solving process. So first we collect the aluminum waste from the scraps. Then we have to do the sorting is important. The one point is important. I'd like to stress on this point: how to sort aluminum waste. So we'll say we have 7,000 series aluminum products. We have 6,000 series, 5,000 series, but we should not mix them up. So some companies want to have only 600 series aluminum scraps, not 700, because 700 contains some amount of zinc in itself. So 6,000 guys hate to have zinc in itself. So hey, to share, why don't you separate those scraps from each other? So at this moment, it's not possible in industry in Japan, but it's possible inside laboratory, university. We have found such a theory. Theoretically, this is possible. So that scheme is the first stage is sorting, and the second is refining, reduction of impurities, and then alloy design containing some amount of impurities that we say stray element. So even the scrap recycled aluminum alloys contain some amount of stray elements such as europium, scandium, yttrium. So why these elements are now in my alloys? So I don't know, who cares? But there is such amount of impurities. So how to remove? You cannot do that. So then how to design the new alloys containing that nasty elements inside. It's okay. We can overcome new alloys by producing new alloys. That is alloy designing, guys. Then plastic deformation. I mean extrusion. That is the main products in Toyama Prefecture, Japan. So how to extrude those alloys without any trouble. That is a challenge for those guys. And then surface modification, surface treatment process, and finally come to my field. I'm a welding man. So yeah, I'm a welding guy. You didn't know that, okay? So that point is very nasty, very hard for me. So if something happens during the prior process for refining, there's something missing in refining process, our designing made some mistakes, and extrusion guys say, I didn't do nothing harmful, but actually in welding it broke. So I'm like a policeman. So you did. So that system is available in Toyama University. Also open for international sectors, for example, Thailand. So last January, I came to Amata, close to Bangkok, Amata. Okay, so many Japanese people are working there, and I talk to them. So the point is sorting and refining. 2 points are required in front of us to realize the carbon neutral society in Japan, also in Thailand also. So next slide will be last slide. I need to conclude my talk because my time is over. So this is a key technology in Japan. So something is secret. So you do not talk to any other guys outside of this conference room, okay? Promise me. And using a tin, a molten tin. Tin is a very useful material for aluminum and silicon. Both elements are in a liquid state in molten tin. So if you reduce the temperature of molten metal, so first the silicon comes up as a solid. Okay, we can extract silicon from the molten aluminum, silicon, and tin pool. So by just changing the temperature of molten pool. Yes, exactly. So then again, we reduce the temperature below that temperature, okay? I mean the solubility of aluminum inside molten tin. So first we extract silicon. And then secondly, we extract aluminum, solid aluminum from the tin. So then we separate the silicon from aluminum silicon alloys. That is our new technology. We have also realized in laboratory level, but in industry level, so no one has succeeded in doing this. So there are many points and many small engineering process we have to conquer. So last slide, and I like to emphasize the certificate. This is something relevant to a CBAM program in Europe. So unfortunately, Japan doesn't have such a unified, just like the Japan CBAM. We don't have such law regulations in Japan at this moment. Now we are struggling to do this, and this is very simple. That first we get scrap, then sorting, refining, alloy design, and extrusion, surface treatment, and finally welding. Each process, each step of that recycling process has the data in its own data. So in our data center gather those individual data in one machine computer, I mean. So visualize the process in terms of energy consumption, in terms of the changing of material properties, both items are on the same spreadsheet. You can easily check the product. There is a QR code on the products would be, and if you see that QR code, so hey, this product is reproduced from that scrap. Who made it? What amount of energy is consumed? And what is material properties? What will be going on if you use this material at elevated temperature? What would happen? No one knows. But the AI, artificial intelligence system of this institute would show you a very highly precision answer to you. So the optimization certificate, the next step of our challenge. Thank you very much.
Arigato gozaimashita, Toshiya-san. Spoken like a true researcher. I suddenly remember my past life as a graduate student at the Tokyo Kogyo Daigaku. So, but nonetheless, I think you expounded on several very important topics, including the importance of research and development in the whole scheme of, well, in this case, aluminum production. No? But I think we have also companies here who are engaged. We have partner industries engaged in aluminum recycling, and Toshiya-san actually posed a challenge. He said that if you could lower the impurities further in the aluminum ingots, you would become very rich. So this is a challenge that was posed to everybody, and I hope we have Daiki and Thai metal aluminum in the house. Maybe you could start really thinking of how this particular challenge that was posed earlier would be very beneficial to